Dr. Michael Metzger is a scientist and researcher at Dalhousie University who arrived in 2021 when its partnership with Tesla was renewed. Metzger joined Jeff Dahn, a lithium-ion pioneer, to help create a cutting-edge technology incubator. Metzger comes from the corporate world and now enjoys contributing to academia and teaching the next generation of battery innovators. I'm thrilled to welcome my next guest, Michael Metzger. Hi, Michael. Thanks for joining me today.
Hi, Maria. Thanks for having me. It's a pleasure.
I'm really excited because I know that you and your colleagues are doing amazing things. And before we dive into that, I want to get a little bit of a sense for everyone to know. Could you tell us how you got to where you are now?
Yeah, absolutely. So, my name is Michael Metzger. I'm an assistant professor here at Dalhousie University in the physics department. And I'm also one of three principal investigators in the Tesla Dalhousie Research Partnership. But it was quite a bit of a journey to get here. So
Right.
maybe I start with my PhD degree, which I did in Munich, Germany, at the Technical University of Munich. And that's where I got my sort of first exposure to the type of research that I'm doing now. So work on lithium-ion batteries and other advanced battery technologies. And then I went to the San Francisco Bay Area, actually, in California, and I worked for a tech company for about 4 years. That was also quite interesting. We worked with startups in the area, and we worked on novel battery technologies. And then this sort of idea of leading my own research group was really exciting to me, and that's how I found my way to Dalhousie University here in Canada.
Excellent. So with how did you get involved with the research lab partnership? And from what I understand, it's the Don Metzger Young Research Lab. Is that the
Yeah, that's
correct?
right. So that's how we call us. So these are basically the names of my colleagues, Jeff Dahn and
Mhm.
Chongyin Yang. And together, we lead the Tesla Dalhousie Research Partnership. And that's a really important project for the university. It's basically a very intimate partnership we have with Tesla. Tesla is our exclusive research partner. That means we don't work with any other company in the field. And that, of course, also means, that Tesla is comfortable really sharing a lot of information with us. And, we get to work on the really tough problems that they are trying to solve with their battery technology, which is, of course, an absolutely essential part of Tesla's products, right? So, basically, when I came here, this research partnership already existed. Jeff Dahn has founded this research partnership together with Tesla in 2016. And then when I came in 2021, the partnership got extended and two new positions were created. And one of those positions is the one that I'm having now. So basically, it's a sign, of Tesla's commitment to this partnership, to the value we bring to this partnership. And we're super excited, to continue this work together with Tesla.
Wonderful. You were telling me earlier about there are five main goals. Is that the goals of the lab or the goals of the partnership? And what are those five?
Yeah, these goals, I would say they are pretty much the goals of almost everybody that's working in this field. So, we are trying to make a contribution, but that's not to say that there are not other amazing research labs around the world that are trying to solve, similar problems that we do. But I would say we have our own sort of spin to the
Mhm.
type of battery research we do. So you're right, we sort of thought about how do we structure sort of the work that we do with Tesla, and we sort of carved out these five big goals that we want to achieve. And they are basically, cost. So, we need to reduce the cost of battery technology because batteries are still the most expensive component in an electric vehicle today. We want to increase the energy density of modern batteries, because that means, if you have more energy density, so more energy you can store per volume or per mass of battery, that means you can have a longer driving range, for example, right, which would be great. Then we very heavily focus on the lifetime of lithium-ion batteries. We believe, there is no reason why they can't last many decades, like 20, 30, 40 years, right? Then, of course, we also make a lot of our own materials and battery cells here in the laboratory, and safety always has to be the top priority, right? So with every new technology we develop, we have to make sure it's safe. And then recently we became very interested in sustainability, and of course it's a very important topic. So, we want to increase the share of abundant, sustainable elements in batteries, because it's not always the case that all the elements we're using are super abundant and mined, under environmentally friendly conditions. So we want to change that in the future.
5 great goals. Wonderful. So the lab is testing a cousin of the lithium-ion battery. Did you want to tell us what that is and how that's all working and coming together?
Yeah, that's a good term, actually. It's really a sort of a cousin to the lithium-ion battery. So, of course, the lithium-ion battery has been an incredibly successful technology, right? So since the commercialization of lithium-ion batteries in 1991 by Sony, it was first used for portable electronics, and it still is, of course. But, then it was really a success story to the point where now, lithium-ion batteries power many of our mobility applications, our electric vehicles, e-scooters and whatnot. But also, of course, they are a very important technology for energy storage on the electricity grid, right? So if we want to have more renewables that are intermittent, we need batteries. So, that means battery technology will ramp up like crazy, and we need to produce so many of them. And so we believe it's very important to have battery technology that does not rely on lithium alone, so that's why we developed the cousin of the lithium-ion battery, which is the sodium-ion battery. So sodium is right next to lithium in the periodic table. It's also an alkali metal. It has a lot of the same properties, and that's why it can also be used in rechargeable batteries. But of course, there are many challenges if you want to replace lithium by sodium, and we work on those challenges. So you need to use different materials for the positive electrode, different materials for the negative electrode. Also, the liquid electrolyte that allows the sodium, in this case, to move is different. But of course, also many things are the same. So, for example, in a battery factory, you could very easily change the materials and use the same equipment to manufacture sodium-ion batteries. So from that point of view, it's a very attractive technology. And also a lot of the characterization techniques that we use here in the laboratory can be applied to sodium-ion batteries. So for us, it's a great research topic, really at the forefront of what's currently been done. And it's also a highly sustainable, low-cost technology, because sodium is extremely abundant. It's in our seawater. It's very cheap and abundant. So it's a good battery technology to work on.
That's wonderful. So you could use seawater, or it could be mined. Like there's different ways you can get the sodium. Is all sodium the same, I guess? Like, is there certain ways that it can be best applied here?
Yeah, so the advantage is really that, lithium is a very localized resource. You can mostly find it in South America, Bolivia, Chile, Argentina. It's a so-called lithium triangle. And then you need to refine the lithium into battery-grade lithium hydroxide, lithium carbonate. That mostly happens in China. And then battery manufacturing happens in different places of the world. But sodium, you can basically find it anywhere, right? And you can very easily refine it too into battery-grade sodium carbonate, sodium hydroxide. And that just makes it a lower cost a more sustainable resource, which alleviates also some of these supply chain challenges. If you need to look for a particular resource only in one part of the world, then ship it all around the world to be refined and so on. That's of course not a very good situation, right? And with sodium, you can circumvent this.
And then there's the other side of with sodium ion compared to lithium. You were telling me earlier that the size is different. Like you have to pack more into the battery. It's a big battery right now. It needs to be a little bit more compact.
Yeah.
That's what you're working on?
Yeah, basically the keyword here is energy density again.
Right.
So, the sodium ion batteries have generally a lower energy density than lithium ion batteries, which means if you have a limited amount of volume, for example, in an electric vehicle, it's more the volume than the weight, which constrains the battery. So in that limited volume, you want to pack as much energy as you can. So if you do that with high energy density lithium ion batteries, you can have a longer driving range. But, in fact, I'm just coming back from a research conference in China, and over there, sodium ion batteries are really on the rise. And, for urban mobility, for example, in e-scooters or for shorter range electric vehicles for a mega city environment, sort of where people don't drive that far, sodium ion batteries can be a really attractive technology. And we are also working on improving the energy density. So that comes at least sort of into the maybe 80-90% range of what the energy density of lithium ion battery is.
You alluded to this briefly earlier. Tell us a little bit more about your relationship, what that's like with Tesla.
Yeah, it's a pretty intense relationship. Tesla, they are moving fast. So they are super creative and driven, by their mission to accelerate the transition to sustainable energy. And we very much, agree with them on that mission and want to make a contribution to that. So it's a pretty intense partnership. We get a lot of tough questions from them. And we have a very close exchange with their scientists and engineers. So typically we have a conference call every 2 weeks where we present the research results that we generate here in our laboratory. And we get immediate feedback, from Tesla. There is a lot of discussion back and forth. We sort of realign based on where we can have the highest impact. We also have more focused calls with smaller teams in Tesla where we discuss other technologies in more detail. And overall, I would say, it's an amazing partnership because our students get exposure to real world problems. They sort of get a bit of a sense what it's like to work in an industrial R&D setting, even though they're at a university. And at the same time, we get to publish almost everything we do with them. So that's, of course, very important for us as academics.
Right. And that was my next question is what initiatives are you working on and what's next for you?
Yeah, we have a few things in the pipeline that we're pretty excited about. And I have to say, this is mostly sort of initiatives that I'm bringing forward with my colleague Changyan Yang, who's the Tesla Canada Chair. And, as a team, we created a concept paper for a master's program that we want to launch here at the university, and it's sort of moving, through the different stages, and it's looking very good that we can launch this program, which will be a specific training program for the workforce that we need to develop here in Canada if we want to, have more battery production facilities. And you may have heard that, there are big investments made in Ontario, Quebec, by companies like Volta Explore or Northvolt, and all these factories will need a lot of trained workers, and our mission at the university is to train folks, right, to train people. So with this master's program, we will be able to contribute a lot to the workforce training here in Canada. And then Changyan and I, we also recently received substantial funding, which we are extremely excited and grateful, so excited about and grateful for, and that is for a new prototyping center. It's called the Canadian Battery Innovation Center, and this will be a user facility. So, other academics across Canada or also worldwide can come to us, use high-end battery prototyping infrastructure to make their own prototype lithium or sodium-ion battery cells. So this will be real-world cells made on professional production equipment to do very meaningful research, that's no longer on the very small benchtop scale where sometimes results are not so comparable and so on. So this will be a real boost, we believe, for the Canadian battery industry, because we also want to make this infrastructure available for startups, or materials companies that don't necessarily have all that equipment to process their materials into batteries. So this will be great. And then lastly, we are also super excited about hosting a big battery conference here in Halifax in September 2024. The conference is called IBA, International Battery Materials Association. And we will bring all the world experts in lithium-ion and sodium-ion technology here to Halifax. And for sure, it's going to be a great week.
Excellent. Well, thank you so much. I mean, for all the information. I think it's really amazing how, in our backyard and in Canada, that you're here and that you choose to stay here and continue with the work. And it's great to see there's a master's program and a center and a conference. Lots happening. It's exciting.
Yeah, thanks so much, Maria. It's the best place to do lithium-ion battery research. At least that's my personal opinion, and I'm super excited to be here.
Well, that's great. Well, I wish you and your team and colleagues all the best, and I'll hope to have you back again. Maybe we can talk further about all the other advancements that you're making in the battery world.
Sounds great. I'd be happy to come on again, and thanks so much for inviting me.
Thank you. That was Dr. Michael Metzger talking about the need for global talent in battery technology. He also gave us a snapshot of the work underway at his world-class battery research and development facility at Dalhousie University. Thanks again for joining. This podcast is sponsored by Smart Energy, a clean energy technology conference held each year in April. Make sure you register before it sells out. I'm your host, Maria McGowan, and thanks for listening and/or watching today. See you next time.